So, today is Get Over It Day. What a great song we prepped with. Here is our agenda. We're gonna jump into some announcements and then JK, this is the wrong agenda. I updated it in a million places. Check this out. I'm gonna do a live time with you. Then we're gonna do notes and then we're gonna do assignment, right? So our standard practice, we are back at it. Our announcements are this. It is week 9, y'all. I almost don't have enough fingers for this. It is week 9 of quarter 3. This week, we're going to have 2 more assignments, right? So we'll have today's assignment and Thursday's. And then for week 10 and week 11, we're going to have our PT. And I talked to our TAs. They are planning something super special for y'all. So it's going to be awesome. And it's going to be about financial literacy, which means like how to deal with money, like taxing and savings, debit cards, credit cards, all different kinds of stuff. That's super important because y'all are about to turn 18, which I know feels like far away, but oof, adulting 101, that's what we're doing the next couple weeks. So should be rad. We had some amazing improvement last week. So many people, look how many people are 100% are like totally caught up on our triangles unit. I am super pumped. I'm also super pumped for the people who moved themselves into 30 and 31 and got some assignments done. This is just a reminder. If you see your name over here, I still need these assignments from you. Each of these assignments is worth about 5% on your grade. So if you were to turn in an assignment, your grade would go up 5% right away, which would be baller. So if your name is here, please do reach out. And I'm going to have Miss Yama just remind you about her stars. Sorry, Miss Yama, to put you on the spot.
Wait, what did you say again?
Yeah, can you just remind everybody what time your office hours are at and how you can get here?
Yeah, great. So my office hours are on Tuesday, Wednesday, Thursday from 10:30 a.m. to 12 p.m. And then you can also make appointments with me on Friday. So just let me know and we'll be able to meet.
Yeah, and those are here at this link. So you just come back to my link. If you have Spanish, go to Spanish first and then come back. Or if you have an open block first, come here and then go to Spanish at your time. So cool. Great job, everyone, on getting caught up. That is the announcements portion of our day today. Is there anyone who has any questions about the announcements before we head into our notes? Anything? I did have a question about modules closing. Modules are going to close in week 11. So I will give you an exact date, but it'll be Wednesday of week 11. That's when you will not be able to turn in anything else. All my modules were closed. So for right now, everything is open, so you can make that happen. Cool, thanks for that question. Amazing. Let us rock and roll into our notes for today. So I'm gonna go ahead and open up some breakout rooms. If you want to go to team, oh, JK, my breakout rooms are broken. Okay, my breakout rooms are broken. So just let me know if you want to go to a breakout room to do team video. I am happy to make that happen for you. If you would like to jump into that room, let me know via messages. Otherwise, we're going to jump into our notes. So go ahead and grab your pencil. I am going to throw this question to you, which is, are you ready to go? Do you have a piece of paper, pencil? And are you ready to take notes? If you want to grab the notes page, it is on Canvas. Looks like a couple of us need a minute, so go ahead and take that minute. Love it. Thanks for letting me know. You need that minute. I'm here for it. All right. If you are already ready, you can go ahead and title your notes Law of Signs. And if you are a super baller, you can go ahead and make sure that you label them Notes 32. Notes 32. All right. I do not need you to draw this. So if you're in the middle of drawing, you do not need to draw what is on the screen right now. We're going to talk about it, but you do not need to draw it. Right? So you do not need to draw it. It's helpful. You can draw it if you want. But I want you to take a look at this section here. And I would love to hear, make this, what do you see? What do you notice? Right? What do you notice? And what do you wonder? What do you notice? So first thing I noticed, there's a triangle, right? That's the first thing I noticed. I would love to hear what other things do you notice or wonder? Amazing. Wendy sees different colors. Yes, I see a blue. I see blue happening here. I see orange happening here. I see green happening here. Amazing, Wendy. Emiliano notices that they're in color groups. So the blue 117 and 1046 is up here for sure. The numbers are different colors. Yeah, definitely. Absolutely, Josh. Sebastian noticed that each corner and side have a number filled, right? So this corner, which is called an angle, great job, Sebastian. This angle and this side, right? They're filled. All three sides are given and all three angles are given. Jasmine notices that there's degrees on every angle. Wendy noticed that all of the answers, check this out over here, y'all. All of the answers are the same. Wow, that's awesome. All the answers are the same. 11.73 is the answer for each of these problems. Amira noticed that there are red dots at each end. Yeah, for sure, Amira. Those are like they're called vertices, right? They're called vertices or like vertex, but in the plural form when there's more than one, vertices. They all have the same answer. Absolutely, Emiliano. Nayeli, great point. They are all sine. Look, check it out. Nayeli's noticing that there's no cosine, there's no tangent here. They're all sine. They're all equal to 11.73. They all use sine. Yeah, that's super interesting, huh? So 10.46 and sine 117. What do we notice? Do you notice anything about the order of the fraction? Do you notice anything about the order of the fraction? Like what's on top and what's on bottom? Yeah, Roxana, go ahead, come off mute.
So the decimals are the numerators and the whole numbers are the denominators.
Ooh, so whole numbers are down here. We had decimals up here. Interesting. Nayeli is also telling me in the chat that the angle is on top. I'm not sure I agree, Nayeli. Where is the, like this 117, is it on the top or is it on the bottom? Oh, side, yeah. Okay, so Nayeli is telling me that the sides are on top and the angles are on bottom, for sure. For sure. I love that. Is that true for all of them? That's true for blue. Is that true for green? The sides are on top, the side is on top, and the angle is on bottom. Yeah, is that true for orange? Side is on top, angle is on bottom. Yeah, it is, right? So we notice that with sides on top, angles on bottom. What else? Right now, I know that I had sine. Did anyone notice that sine is also always on the bottom? My sine also goes with the angle. Yeah, Josh noticed that, right? The sine goes with the angle. That's on the bottom, right? For sure. One thing I wanted to point out, I think Emiliano hit me with it earlier, is that the side, the angle is blue here, and it's across from my side here. Notice how they match, how the colors match, right? 117 degrees goes with 10.46 on that side there. What does 36 degrees go with? What does 36 degrees go with? What side does it go with? .9, yeah. 6.9, orange 6.9 for sure, right? And then what does 25 degrees go with? Yeah, Joy, absolutely, 4.96. So you all told me that we're only working with sine here. We're also always working with our opposites. From the angle, we're going opposite, right? From our angle, we're going opposite. From our angle, we're going opposite, right? So what you all are seeing here is an interesting pattern. When I have a side and its angle that is opposite, the relationship between that side and angle is the same no matter what side and angle we're talking about. So what we are going to, what we are seeing here is called the law of sines. Okay, I want you to write this down with me on your paper. Make sure you have the word law of sines. And the law of sines says this. The law of sines says A over sine capital A is equal to B over sine capital B is equal to C over sine capital C. So what I'm saying here is if I put the sides on top, if the side is on top and the sine with the angle is on bottom, no matter which angle pair or like side angle pair I use, no matter which one, they're all going to be equal to each other. Many of you are able to tell me, oh, look, all the 11.73 is the same for all of them. Right, so in this case, we have our sides are all on top, A, B, and C. Notice I use a little letter to talk about my sides. And I use a capital letter to talk about my angles. My angles are all on the bottom here. Wow, such a cool relationship that you all found in that triangle. Love it. We can, and we'll see this on our last example today, we can flip this law of sines over. We can put the angles on top and the sides on bottom, right? It is possible to do that and the relationship will hold true, right? So we could alternatively write this as sine A over A equals sine B over B equals sine C over C. We can flip it over if we would like to, right? This is also a possibility. And we'll see when that is helpful later on today. Yeah, you should make sure that you have our blue, everything written in blue here. And the second version as well. I would write down both of them. So everything in this box should be on your paper. All right, I'm going to leave that up here. I want us to go ahead and write 3 equal fractions based on this new triangle here. So here's our new triangle. We have the 3 angles and we have the 3 sides. I'm going to go ahead and write the first angle side pair, right? So I'm going to say the first angle side pair that I want to write is 61 degrees is opposite 5.56. So I'm going to go ahead and write 5.56 over sine 61. Those have a relationship to each other. Notice that I'm putting the angle with the sine. The angle is always going to go with sine. So I can make that note on my thing here, always with sine. This is one of the fractions that is from this triangle. When you go ahead and write on your paper, go ahead and write on your paper, I want 2 other fractions. 2 other fractions that are equal. And if you can tell me in the chat, that would be awesome. Tell me in the chat if you can write me another equal fraction from this triangle. Jasmine, almost right, but don't forget your sign. Where does your sign go? Yes, absolutely. Jasmine told me that 77 degrees is opposite of 6.23. So she wrote the fraction 6.23 over sine 77. Absolutely. 6.23 over sine 77. I like it. And then I've got some more, lots of other versions here. Absolutely. Marcy, Sebastian, Emiliano, Noemi, Zephyr, Roxana, great job. Okay, so those are the correct order. I see some people are saying 4.27 should go on top, and some people are saying 42 should go on top. If I have my sides on top, which one should go on top? What number should go on top here? What's my numerator? Yeah, absolutely, 4.27. Right, so here's my angle, that's my side, 4.27. These are my sides on top. And then I got one answer that said 4.27 over 42. What's missing from this answer? Sine, yeah, we wanna make sure that we have sine. Should I put sine with the numerator or sine with the denominator? Where should my sine go? Denominator, yes. Denominator. So we're able to write 3 equal fractions using the angles and sides that they give us. Cool. Okay, we're going to do 2 examples today because so this is really helpful to us, but sometimes it's going to, there's going to be missing numbers, right? We're not always going to have all 3 angles. We're not always going to have all 3 sides, right? So sometimes there's going to be some missing information and we're going to be like detectives figuring that out using the law of sine. So let's go ahead and draw this triangle on our paper. So I do want you to actually draw out this triangle. And I want us to be careful here. The A is a side, it should be on the outside. And 5.67 is a side, it should be on the outside here. Okay, so go ahead and draw this triangle. We have 47 degrees here. We have 34 degrees there. We'll make it bigger for us right now. All right. All right, so we have this triangle. The question asks, it says problem 1, what is side A? That is the thing that I am trying to figure out, right? What is side A? So side A is going to go on the top. Side A is the thing I'm trying to find out. Do sides need to have the sign with them? Do sides have sign? No, they don't have sign, right? Just the angles have sign. All right, so if I have A, what is the angle that is opposite? What is the angle that is opposite of A? Yeah, for sure, 47. So I'm gonna have 47, and remember it's an angle, so I'm gonna put sine with it here. So A over sine 47, those two go together. And that's gonna be equal to another pair. Can someone write me the other pair? What would be the pair that I need? What other fraction am I gonna be here? Yes, Gabby. All right, remember I have my sides on top. All right, my side is on top. The side in this case is 5.67. and that is across from its angle. It has to go with its angle pair, right? Its angle pair, which is sine 34. We can put our degrees there. We should put our degrees there. Amazing. All right, so now if I want to get A by itself, I've written an equation now. If I want to get A by itself, how do I get rid of divide by sine 47? What's the opposite of dividing? For sure, multiplying. Yes, multiplying. Right, I'm going to multiply sine 47 on both sides. Absolutely, great job, Nayeli. All right, that action is going to help me cancel my signs and leave me with just A equal. And then I have all of this business over here, right? I have 5.67, I have sine 34, and I have sine 47, right? All of this looks like something, there's no variables left in here. So it looks like something I'm gonna put in my calculator, right? So I'm gonna find my handy dandy decimal, right? And I wanna type this entire thing. I wanna type 5.67 divided by sine 34. I'm gonna type that in here, and then I'm gonna multiply it times sine 47. So first things first, I'm gonna go up here, check that I am in degrees. I am, right? Wanna make sure that my calculator is in degrees. I'm gonna type in here, 5.67 divided by, I'm gonna go sine is in my functions, sine 34, right? I wanna put this whole thing in parentheses, so I'm gonna click over here, and I'm gonna press the back parenthesis, the end parenthesis, like that. And then I want to multiply times sine 47 times sine 47. Right? And I get 7.415. I'm going to use one decimal place today. One decimal place, that's what our homework will use for 7.4. 7.4. There are no units right now. There's no units on the 5.67, so I don't know 7.4 what, I don't know, but it is 7.4. 7.4. Just like that. So I know that A is 7.4. This makes sense to me because 34 was a little bit smaller than 47. So my angle 34, a little bit smaller than my angle 47. So the side that goes with it, 5.67, should be a little bit smaller than the side that goes with the other angle, 7.4. Right? So if I have a big angle, I should have a big side. If I have a small side, I should have a small angle. So they have that relationship because they're dividing. All right, let's think about our steps. What was the first thing that we did here? What was the first thing that we did? We found our sides and our angles. Yeah. We wrote the pairs. Yeah, we decided what was going to be on top. Okay, I like all these ideas. All right, we wrote the pairs. We wrote the pairs, and we had to decide what was going to be on top. And we decided what was going to be on top by looking for what we had. Right? For sure, we found our sides and our angles. Right? And then once we wrote our pairs, what was our second step? So once we wrote our pairs as an equation, this part here. Yeah, Melanie, we solved for A. We solved for A. Right? We got A by itself. We did that by multiplying the sine 47 over here. Sine 47. I saw a question come through the chat. What if there was a number where instead of the letter where A is, like what if there was a number here? If there was a number, like if there was a 7.4 here, then we wouldn't have a problem to do, right? We wouldn't know what to do next, right? We could, I guess, we could use these two angles to figure out what that angle was, and then we could solve for this side over here. But in our problem today, there's going to be something that we're looking for. There's going to be a variable somewhere. Sometimes, though, the variable might be in the angle. Sometimes the variable might be in the angle. So that's what our second problem is going to be for today. Right? So that is what our second problem is going to be. Go ahead and draw this triangle down here. And again, I want to note that the 6.08 is a side. It should be on the outside here. 6.08 on the outside. Go ahead and draw this triangle here. Draw that triangle on your paper. All right. So we're going to follow the same steps for this problem. The first step is our angle side pairs. We're going to write that equation first. And then the second step is to solve. This time we're going to be solving for B. Okay. So this time we have B, and B is an angle. So this time I'm going to have sine B, sine B, and what side is its opposite? What side is its opposite? Yeah, good job. 4.53 is its opposite side, its angle pair. Good job, Emiliano. Great job, Jasmine. Great job, Noemi. Right, 4.53 for sure. Those are pairs. Go ahead and take a moment. What is the other? What is the other pair? What is the other pair here? Great job, Melanie. Great job, Roxana. Great job, Jasmine. The other pair is 88 degrees and 6.08. Right? 88 degrees. Since I had sine B, since I have my angles on top this time, I'm going to have my sine 88 degrees on the top on this one. Right? So I like that these are matched. They have a relationship to each other. Sine 88 and its side pair 6.08. Absolutely. Nayeli's already got me on my next step. My next step is to solve for B, right? I want to get B by itself, right? I see divide by 4.53. So my next step is to multiply, right? I want to get 4.53 to go away. 4.53, I'm going to multiply it on both sides. 4.53. What is going to be left on the left side? What's going to be over here? What's going to drop out of this? Yeah, absolutely. Sine B. Sine B. So notice it's not just B that's dropping out, but actually sine B. And then what should I do with all of this other business over here? What should I do? I have sine 88 over 6.08 times 4.53. What should I do with this? Yeah, decimals. Plug it in your calculator. Right, so I'm going to plug this part in my calculator. I'm going to have sine 88. Notice that there's parentheses here. I want to get out of those parentheses and do divide by 6.08. If I don't get out of those parentheses, look what happens. divided by sine 0.08. You see how how now that 0.8 is with the sign? I don't want that. Right? I don't want that. So I'm going to get out of those parentheses. Press divide by 6.08. Right, so now I have this portion. I'm going to click out on the back end side over here. So I get that big parenthesis and then times 4.53. Right, I get, that's a weird looking angle, 0.7446, right? A big long decimal. That's weird. That's not my angle, huh? I don't think this angle is like less than 1 degree. That'd be like so small, right? Does anyone remember? Okay, so sine B equals this decimal. How do I get just the angle? How do I get rid of sine? Does anyone remember from last week? Yes, sine inverse, right? So I can't subtract sine, right? Sine is like a thing that I'm doing, right? To be, it's its own thing. It's not like a positive sign, right? I have to use its inverse, right? Its inverse, remember, is the inverse sign is sine -1, sine -1. And what I do on one side, I always have to do on the other side as well, sine -1. So I'm going to do sine inverse of this side, sine inverse and sine. What happens with sine inverse and sine when they're right next to each other? What happens to them? Yeah, they cancel right out. They cancel each other out. So I get B, so angle B equals, and I have to do sine inverse of this number here. So I'm going to go ahead and click onto my second line of my calculator. I'm going to go to functions. This time I'm going to press sine -1. And then I'm going to type in a lot of these decimals. I'm going to type in 0.7446, right? Notice my number's still changing here, so I'm going to keep going. 119155526. I'm just going to quickly do this. If you are on your computer, you can copy and paste from here into the next line. My iPad won't let me do it. So we have 48.12577, da, da, da. Right? I'm going to use one decimal place, 48.1. The 2 is not going to round up, so I have 48.1. Does that seem like a more normal angle degree? Yeah, that's way better than like 0.07. That's not going to make any sense. So when we have angles, right, when we're solving for an angle, that's when we have our second step of using the sine inverse. Using the sine inverse, and we get 48.1 degrees for our angle B. Again, that makes sense to me because the big angle went with the big side, the small angle went with the small side. So I can check my work by thinking about it that way. All right. Here, I had my first step was making my pairs. That was my first step. My second step was my solving by multiplying. My third step was solving by using sine inverse. And then I got my answer, right? I guess my next step was in the calculator. My D step was in the calculator, and E means I got all the way to the end. I'm going to send a poll to you. I want to know where, if you got stuck or if it got confusing, where did it get confusing? Did it get confusing at A, where we were making the angle? Did it get confusing where we were multiplying? For C, did it get confusing where we were doing the sine inverse? For D, did it get confusing when we put it in the calculator? Or for E, did you make it all the way to the end? Make sure you vote in that poll. Where did it get confusing for you? So if you were getting confused on part C, The only thing you just have to memorize is that if we have sine B, right, the opposite of sine is sine inverse. Right? The opposite of sine is sine inverse. So that is for C. If you're getting confused on part D, you're literally just typing in what you see. Whatever you see is going to go into the calculator. And then you're copying that answer in here. If you got to part D, great job. Got to part D, great job. Part A is still confusing. That is okay. Got it. All right, I'm going to end this poll. Thank you to those people who voted. Appreciate you. All right. I am going to go ahead and go back to my pre-assigned here. All right. If you have any questions, Miss Yama is going to pop into a breakout room and continue like helping anyone who has any questions. For your assignment today, I'm going to go ahead and show you what your assignment looks like. For your assignment today, you have your notes section. You already got 10 points. Great job for doing your notes. You do have options for either doing it on paper or doing it on the computer. So you have two options there. If you want to do it on paper, there are help videos for number 1, number 2, number 7, and number 9, right? Number 1, 2, 7, and 9, there are help videos. And there is an answer key if you're doing it on paper. And then your last one here is your checkpoint form per usual. There are 3 questions. Your goal is to get 3 out of 3. 3 out of 3. Got a little bit of a lag going on there. All right, here's what I'm gonna do. I'm gonna go ahead and pop you all. Give me one moment here. All right. All right, team. Here's what's going to happen next. I'm going to go ahead and pop you all into a breakout room. The notes portion is done today, but you should be working on your assignment portion now, right? So in that breakout room, you're working on your assignment question. You have access to someone to help you if you do want or need that support. I'm going to go ahead and open up these rooms. So I'm going to say bye, but Ms. Yama and Ms. Flores will be there to greet you in your breakout rooms. Go ahead and join your breakout room. You're working on finishing your assignment before the end of the day. Thanks, friends. Go ahead and jump in. Jump in, jump in. Go ahead and jump into those breakout rooms. Yeah, Melanie. Yeah, I just switched you, so you should be good if you take that breakout room. Helen, I just switched you. You can go ahead and jump into that breakout room. Gary. Yeah, Nebu, you should. Oh, just kidding. There you go, Nebu. Jasmine, you should be good to go too. Molly, Allen, and Molly, go ahead and jump into that breakout room if you'd like. Hi, pre-calculus. Welcome.